There's something almost magical about looking up at the night sky, those countless points of light, scattered like diamonds on black velvet. But what if I told you those stars aren't just silent spectators? What if they're whispering secrets, hiding messages in plain sight, waiting for us to crack the code? This isn't science fiction. It's real. For centuries, astronomers and stargazers have stumbled upon strange patterns, baffling anomalies, and cosmic coincidences that defy explanation. Today, we're stepping into the shoes of cosmic detectives, piecing together a puzzle written in the language of the universe itself. Think about this. Ancient civilizations built monuments aligned with the stars with precision we can barely replicate today. Modern telescopes capture signals from deep space that don't match any known natural phenomenon. And then there are the numbers, mathematical constants hidden in the orbits of planets, ratios so perfect they seem intentional. Could these be clues left behind by the cosmos? Or is there something even more extraordinary at play? Whether it's the eerie symmetry of galaxy clusters or the mysterious radio pulses repeating like clockwork from distant galaxies, the universe is anything but quiet. It's speaking to us. The question is, are we listening? This journey isn't just about solving puzzles, it's about rewriting history. Every discovery we uncover doesn't just add another piece to the cosmic puzzle. It reshapes our understanding of where we come from and where we're headed. From forgotten celestial maps buried in ancient ruins to the mind-bending anomalies spotted by today's most advanced observatories, these hidden messages challenge everything we thought we knew. So grab your metaphorical magnifying glass, because by the time we're done, you'll never look at the night sky the same way again. The universe isn't just vast and mysterious, it's alive with stories, and we're about to decode them together. To crack the universe's hidden messages, scientists don't just rely on intuition. They wield an arsenal of tools so advanced they'd make any detective envious. Take the Hubble and James Webb Space Telescopes, for instance. These cosmic time machines don't just snap pretty pictures. They capture light that's traveled for billions of years, letting us peek into the universe's distant past like flipping through an ancient photo album. But sometimes the universe doesn't speak in visible light. That's where radio telescopes come in. They're massive dishes tuned to the faintest whispers of energy, pulsars humming like lighthouses, or the eerie, repeating bursts from galaxies halfway across the cosmos. Then there's spectroscopy, the unsung hero of cosmic detective work. When starlight passes through a spectrometer, it splits into a rainbow of colors. But here's the magic. Embedded in that rainbow are dark lines like barcodes. Each line corresponds to a specific chemical element, revealing what distant stars and planets are made of without us ever touching them. It's how we've found water vapor on exoplanets and even detected potential signs of life in the atmospheres of faraway worlds. But the real game changer, supercomputers. Imagine sifting through mountains of data so vast, no human could process it in a lifetime. That's where machine learning steps in, spotting patterns and anomalies hidden in petabytes of information, like finding a needle in a galactic haystack. These tools don't just collect data, they translate the universe's language into something we can understand. So when we stumble upon a star that flickers unpredictably or a galaxy shaped unlike anything we've seen, it's not just random noise. It's a clue waiting to be deciphered. Armed with this toolkit, we're not just observers anymore. We're interpreters of the cosmos's grand, mysterious story. One summer night in 1977, a radio telescope at Ohio State University picked up something extraordinary, a signal so intense, so unlike anything we'd ever heard from space. that astronomer Jerry Amon circled it on the printout and scribbled one word in the margin: "Wow." And just like that, the wow signal became one of the most tantalizing mysteries in astronomy. For 72 seconds, this burst of radio waves blared from the direction of the Sagittarius constellation, hitting a frequency that scientists had long speculated might be used for interstellar communication. Then, as suddenly as it appeared, it vanished. No echo, no repeat, just silence. What made this signal so special? For starters, it was narrowband, meaning it was concentrated at one specific frequency, unlike the broad, messy emissions from natural cosmic phenomena like quasars or pulsars. It also matched the predicted signature of an artificial transmission, something engineered rather than born from celestial chaos. Astronomers scrambled to explain it. Could it have been a passing comet reflecting radio waves? Unlikely. No known comets were in that region at the time. A military satellite, no records matched. The most electrifying possibility, that for 72 seconds we might have overheard an alien civilization saying hello. Yet here's the twist: despite decades of follow-up scans, the wow signal never returned. It's as if the universe teased us with a single, cryptic postcard, then left us staring at an empty mailbox. Some researchers argue it was a one-off cosmic fluke, a freak alignment of interstellar gas, or a glitch in our own technology. Others hold on to hope that it was intentional, a fleeting attempt at contact. Whatever the truth, the wow signal does something remarkable. It forces us to confront how little we truly understand about the cosmos. Even today, with telescopes 1,000 times more sensitive, we're left with that same burning question. If the universe is speaking, are we listening closely enough, or are we missing the message entirely? Picture this: you're floating in space, watching hundreds of galaxies, each containing billions of stars, streaming in unison like a school of fish. But here's the catch: they're not supposed to be moving this way. In 2008, astronomers studying the cosmic microwave background, the afterglow of the Big Bang, stumbled upon something bizarre. Entire clusters of galaxies were racing toward a single patch of the cosmos at speeds over 2 million miles per hour. They called it the dark flow, and it's one of the most unsettling mysteries in modern astronomy. Why unsettling? Because according to everything we know, the universe should be expanding evenly in all directions, like a balloon inflating. Galaxies might drift slightly due to local gravity, but this was a coordinated march on a scale that defies logic. Some researchers believe the dark flow could be evidence of something monumental lurking beyond the edge of our observable universe, perhaps a supermassive structure, a cosmic neighbor so enormous its gravity is tugging on us like a magnet. Others take it further, suggesting it might be the fingerprint of a parallel universe, a realm of space-time brushing against our own, but skeptics aren't convinced. Could it be a glitch in our measurements, a trick of the data? After all, the cosmic microwave background is faint, and parsing its subtle irregularities is like listening for a whisper in a hurricane. Yet, even after accounting for errors, the signal persists. If the dark flow is real, it means there's something out there, something so vast, so alien. It's reshaping our corner of the cosmos without us even seeing it. This isn't just about galaxies moving oddly. It's about the limits of our knowledge. The observable universe stretches 93 billion light-years across, but what lies beyond that horizon? The dark flow hints that we might be a small island in an ocean of unseen wonders, where the rules of physics as we know them could be rewritten. Every time we think we've mapped the cosmos, it throws us a curveball, reminding us that the universe is stranger, grander, and more mysterious than we ever imagined. Among the countless stars in our galaxy, one stands out not for its brilliance, but for its baffling behavior, KIC 8462852, better known as Tabby's star. While most stars flicker gently due to passing planets or sunspots, this one doesn't play by the rules. Instead, it dims erratically, sometimes by as much as 22%, a drop so dramatic, it's like watching a light bulb suddenly covered by an unseen hand. The strangest part, there's no clear explanation. When astronomers first noticed these bizarre dips in brightness, their minds raced to the most tantalizing possibility. Could this be evidence of an alien megastructure? Imagine a civilization so advanced, they've built a colossal network of solar panels, a Dyson sphere encasing their star to harness its energy. The idea wasn't pure fantasy. The star's light patterns didn't match anything natural we'd seen before. No planet, no dust cloud, no swarm of asteroids could explain such irregular, deep dimming. For a moment, it felt like science fiction might be crossing into reality. But science thrives on skepticism, and researchers scrambled for less extraterrestrial answers. Maybe it was a family of comets, thousands of them, passing in front of the star in a chaotic dance. Or perhaps interstellar debris, a cosmic traffic jam of shattered planets and dust. Yet none of these theories fit perfectly. The comet swarm would need to be impossibly large, and the debris theory couldn't account for the star's long-term, gradual dimming over the years. Even a rogue black hole was floated and quickly dismissed. What makes Tabby's star so captivating isn't just the mystery itself, but what it represents. It's a reminder that for all our telescopes and supercomputers, the universe still holds phenomena we can't yet explain. Whether it's the remnants of a cosmic collision we've never witnessed or something far more extraordinary, this star challenges us to think bigger. Every time it dims, it's not just light vanishing, it's a question mark hanging in the cosmos, daring us to look closer. And that's the thrill of astronomy. The more we learn, the more we realize how much we don't know. It's a question that's haunted scientists and dreamers alike for decades. If the universe is so unimaginably vast, with billions of galaxies and trillions of planets, why does it feel so empty? This is the heart of the Fermi Paradox, named after physicist Enrico Fermi, who famously posed the question over lunch one day in 1950, "Where is everybody?" On paper, the numbers are overwhelming. Statistically speaking, intelligent life should have arisen countless times across the cosmos. So why haven't we heard a peep? The silence isn't just puzzling, it's deafening. One possibility is as unsettling as it is simple. Civilizations might not survive long enough to make contact. Imagine a species not unlike ours, reaching the technological brink, harnessing energy, building cities, even venturing into space only to collapse under the weight of war, climate disaster, or runaway artificial intelligence. It's a grim thought, but history shows empires rise and fall. Could the same fate await every civilization, leaving the universe littered with the ruins of societies that burn too bright, too fast? But not all explanations are so bleak. Some researchers argue advanced civilizations might be intentionally avoiding us, treating Earth like a wildlife preserve. Think about it. If aliens observed humanity's turbulent history, would they risk interfering? There's also the zoo hypothesis, the idea that we're being deliberately isolated until we reach a certain level of maturity. Or perhaps communication is the real hurdle. Light travels at a cosmic snail's pace. A civilization just a few hundred light years away might not even know we exist yet, their signals still en route across the void. Then there's the sheer scale of time. The universe is 13.8 billion years old, but humans have only been around for a blink. What if other civilizations flourished and faded millions of years before us, their signals now lost to static? Or worse, what if we're the first? Someone had to be, after all. The more we discover, like the thousands of exoplanets nestled in habitable zones, the more the paradox deepens. Every new world capable of hosting life makes the silence louder, more deliberate. So is the universe truly empty, or are we just not listening the right way? Maybe the messages are all around us, hidden in cosmic rays, neutrinos, or dimensions we can't yet perceive. The Fermi Paradox isn't just about aliens, it's a mirror held up to humanity. It forces us to confront our place in the cosmos, to question whether we're alone, overlooked, or simply late to the conversation. And until we find an answer, that silence will keep echoing, a riddle written in the stars. Imagine a flash of radio waves blazing across the cosmos, carrying more energy in a millisecond than our sun emits in 3 days, then vanishing without a trace. This isn't the plot of a sci-fi movie. It's the reality of fast radio bursts, some of the most enigmatic signals in the universe. First detected in 2007, these fleeting pulses arrive without warning, often from billions of light years away, and their origins remain one of astronomy's greatest puzzles. What could possibly produce such violent, brief eruptions of energy, and why do some repeat while others disappear forever? The leading suspects: magnetar's ultra-dense, highly magnetized corpses of dead stars. These cosmic powerhouses spin rapidly, their magnetic fields so intense they could strip the information from a credit card halfway across the solar system. In 2020, astronomers caught a smoking gun, a fast radio burst erupting from a magnetar within our own galaxy, proving these stellar remnants can indeed produce the phenomenon. But here's the twist: not all bursts fit this mold. Some come from regions of space with no obvious magnetars, and others repeat in patterns so irregular they defy explanation. Then there's the sheer diversity of these signals. Some bursts are one-offs, like cosmic firecrackers popping in the void. Others, like FRB 1211-2, repeat with clockwork precision, flashing like a lighthouse on a distant shore. Could these repeating bursts be the aftermath of colliding neutron stars, or perhaps the death throes of black holes? Or dare we say it, might they be something far more intentional? The pulse's brevity and intensity make them ideal for interstellar communication, cutting through the noise of the universe like a laser beam. But the universe loves to humble us. Just as we think we've cracked the code, a new burst emerges from an uncharted corner of the cosmos, upending our theories. Take FRB 190520, which erupted not once, but multiple times from a region devoid of any known celestial objects. It's as if the cosmos is playing a game of hide and seek, leaving breadcrumbs just out of reach. What makes fast radio bursts so captivating isn't just their mystery, it's what they reveal about the universe's hidden turmoil. These bursts are cosmic telegrams, carrying information about the intergalactic medium they've traversed, mapping the invisible web of matter that binds the cosmos. Each one is a time capsule, a snapshot of conditions billions of years ago, waiting to be decoded. Whether they're the screams of dying stars or the whispers of something beyond our understanding, one thing's certain: the universe is far louder, far stranger, and far more alive than we ever imagined. And with every burst we detect, we're one step closer to unraveling the story they're trying to tell. Somewhere in the depths of space, beyond the glittering veil of the Milky Way, an unseen force is pulling us, and hundreds of other galaxies toward it at over 1 million miles per hour. This cosmic puppeteer is known as the Great Attractor, and it's one of the most baffling gravitational mysteries in the universe. Imagine a magnet so powerful, entire galaxies can't resist its tug, yet so well hidden we've barely glimpsed its face. For decades, astronomers struggled to study it directly because it lies in what's called the zone of avoidance, an area obscured by the thick dust and stars of our own galaxy's galactic plane. It's like trying to spot a lighthouse through a thunderstorm. What makes the Great Attractor so intriguing isn't just its strength, but its ambiguity. Early observations suggested it might be a colossal cluster of galaxies, a gravitational anchor weighing in at tens of thousands of times the mass of the Milky Way. But as our technology improved, we uncovered something even grander. The Great Attractor appears to be just one piece of an enormous cosmic structure called the Laniakea supercluster, a web of galaxies stretching over 500 million light-years. Within this vast network, galaxies flow like rivers toward a shared center of gravity, with the Great Attractor acting as a pivotal node in this celestial watershed. Yet the plot thickens. Even the immense mass of Laniakea might not fully explain the Great Attractor's gravitational grip. Some researchers speculate that dark matter, the invisible scaffolding of the universe, could be concentrated there in unprecedented densities, warping space-time like a hidden boulder in a stream. Others wonder if there's something beyond it, an even larger structure pulling the Great Attractor itself. After all, our cosmic neighborhood is like a set of nested Russian dolls. Every time we think we've found the biggest gravitational player, another contender emerges. What's truly humbling is how this mystery forces us to confront the limits of our vision. For every galaxy we map, there are countless others hidden behind cosmic curtains of dust and light. The Great Attractor isn't just a scientific puzzle, it's a reminder that we're still novices in deciphering the universe's grand design. Every breakthrough peels back another layer, revealing not just answers but deeper questions. And as our telescopes grow sharper, who knows what other invisible giants we'll find lurking in the dark. In October 2017, astronomers spotted something extraordinary, a strange, elongated object hurtling through our solar system at nearly 200,000 miles per hour. It wasn't from around here. Named Oumuamua Hawaiian for Scout, this interstellar visitor was the first confirmed object from beyond our solar system, a cosmic traveler passing through like a ship in the night. But what made it truly bizarre wasn't just its origin, it was how it behaved. Unlike comets which spew gas and dust as they warm up, Oumuamua showed no visible tail. Yet it accelerated unexpectedly, as if pushed by some unseen force. Scientists scrambled for explanations. Maybe it was a nitrogen iceberg slowly evaporating in the sun's heat, releasing invisible gas that nudged it forward. Or perhaps a hydrogen iceberg, a fragile relic from deep space that left no trace as it vaporized. But each theory had holes. Nitrogen ice is rare in the cosmos, and hydrogen icebergs would have evaporated long before reaching us. Then came the most provocative idea. Could Oumuamua be artificial? Harvard astronomer Avi Loeb famously suggested it might be a light sail, a thin, reflective structure propelled by starlight, possibly even a piece of alien technology drifting through the void. The debate raged, not just because of the implications, but because we'll never know for sure. Oumuamua was already racing away by the time we noticed it, too faint and distant for follow-up observations. It's like finding a cryptic message washed up on a beach, only for the tide to reclaim it before you can read it. What's left is a tantalizing glimpse into the mysteries of interstellar space. Most objects in our solar system orbit predictably, bound by the sun's gravity. Oumuamua was different, a free agent governed by the tides of the galaxy itself. What's remarkable is how much this lone visitor taught us. Its unusual shape, likely 10 times longer than it was wide, suggests it endured eons of cosmic collisions, sculpted by forces we can only imagine. Its trajectory hints at a chaotic past, possibly ejected from a distant star system during planetary formation, and its very existence implies the universe is teeming with such wanderers, countless silent travelers drifting between the stars. Oumuamua's brief visit was a cosmic wake-up call. It reminded us that the universe is far more dynamic than we thought, full of objects that defy easy categorization. Whether it was a natural oddity or something more extraordinary, one thing's certain: the next time an interstellar guest drops by, we'll be watching much more closely. And who knows, the answers it brings might rewrite the textbooks entirely. In the vast emptiness of interstellar space, where the sun's grip weakens to little more than a whisper, two robotic pioneers, Pioneer 10 and Pioneer 11, began behaving in a way that left scientists utterly baffled. These intrepid probes, launched in the early 1970s to explore the outer planets, should have coasted smoothly into the void, their trajectories governed by the familiar tug of gravity. But something was off. As they ventured beyond Pluto, engineers noticed an anomaly so slight it could have been dismissed as a rounding error, yet so persistent it couldn't be ignored. The probes were slowing down just a fraction more than Newton's laws predicted, as if an invisible hand were gently pressing the brakes. At first, the implications sent shockwaves through the physics community. Could this be evidence of a flaw in Einstein's theory of relativity, a sign that gravity itself behaves differently in the icy depths of interstellar space? Some even dared to wonder, was the universe's hidden dark matter exerting an unexpected drag? For decades, the Pioneer anomaly became a cosmic riddle, a tiny discrepancy with the potential to upend our understanding of physics. Then came the twist. After painstaking analysis, researchers realized the culprit wasn't some exotic new force. It was something far more mundane. The probe's own heat, radiating from their electronics and power sources, was acting like a microscopic thruster, pushing back against their motion. It was a humbling reminder that even in the grand theater of space exploration, the devil's in the details. But here's the thing. The mystery wasn't just about solving a puzzle. It revealed how science thrives on anomalies. The Pioneer anomaly did more than challenge textbooks. It showcased the scientific method in action. When reality doesn't match theory, that's when the real work begins. Every unexplained flicker, every tiny deviation, could be the first clue to something revolutionary. And while this particular enigma had a mundane explanation, it's a testament to the curiosity that drives us. After all, the next anomaly might not be so easily solved. It might just rewrite the rules of the cosmos. So we keep probing, keep questioning, because somewhere out there, the universe is still hiding its greatest secrets. Deep in the silent expanse of Earth's orbit, a shadowy figure looms, at least according to the legend. Meet the Black Knight satellite, a supposed alien observer that's fueled conspiracy theories for decades. Stories claim this enigmatic object has been circling our planet for 13,000 years, a silent sentinel from an ancient civilization far beyond our own. But here's the catch. Astronomers have a far less glamorous explanation. To them, it's likely just a piece of space debris, maybe a discarded thermal blanket from an old mission, or a fragment of a satellite lost in the shuffle of humanity's rush to the stars. So why does the myth persist? It all started with strange radio signals. In the late 1950s, amateur radio operators reported picking up eerie, repeating transmissions that seemed to originate from somewhere above Earth. Then came the photographs, blurry, black and white images from early NASA missions that appeared to show a dark, irregularly shaped object lurking in the background. Could this be evidence of an otherworldly presence or just pareidolia? The human brain's tendency to see patterns where none exist, the most tantalizing twist. Some claim the Black Knight's orbit defies conventional physics, moving in ways human-made objects shouldn't. Skeptics, of course, point out that space is cluttered with defunct satellites, spent rocket stages, and even lost tools from spacewalks, all capable of drifting in unexpected ways. But the legend endures because it speaks to something deeper than facts, our innate desire to believe we're not alone. The Black Night isn't just a mystery, it's a mirror reflecting humanity's yearning for connection in the vast, indifferent cosmos. Whether it's a relic of alien technology or just a forgotten piece of our own spacefaring history, one thing's certain: the Black Night reminds us that the line between myth and discovery is often thinner than we think. And until we can reach out and touch it, the mystery will keep orbiting right alongside our imaginations. Just beyond Neptune's orbit, where sunlight fades to a dim glimmer, lies a cosmic puzzle wrapped in ice: the Kuiper Cliff. Picture the Kuiper Belt as a bustling asteroid belt on steroids, filled with frozen remnants from the solar system's birth. But then, abruptly, it's as if someone drew a line in the cosmic sand. The number of objects drops off a cliff, leaving astronomers scratching their heads. Why would a region so rich in debris suddenly go silent? This isn't just a curiosity. It's a boundary that defies everything we know about how planetary systems form. One leading theory points to an unseen giant planet 9. This hypothetical world, thought to be 10 times the mass of Earth, could be lurking in the distant dark, its gravity herding Kuiper Belt objects into odd orbits or even flinging them into the void. The math suggests something massive is tugging at these icy bodies, sculpting their paths like an invisible sculptor. But here's the catch: no one's actually seen Planet 9. It's a ghost in the equations, a shadow in the data. Could it be real, or are we chasing a celestial mirage? Then there's the possibility that the Kuiper Cliff isn't a cliff at all, just a cosmic illusion. Maybe the objects beyond are too faint for our telescopes to spot, or their orbits are so elongated they only swing by occasionally. Others wonder if the early solar system's chaos played a role. Imagine Neptune migrating outward billions of years ago, its gravity kicking smaller objects into the abyss like a cosmic game of pinball. But the most tantalizing idea: that the cliff marks the edge of the sun's influence, where the gentle pull of our star gives way to the Milky Way's broader tides. Out here, the galaxy itself could be stealing objects away, a reminder that we're not just part of a solar system, we're part of something infinitely grander. The Kuiper Cliff isn't just a boundary, it's a question etched in ice. Whether it's hiding a planet, revealing the limits of our tools, or exposing gaps in our theories, one thing's clear: the solar system still has secrets to spill. And every time we peer into that darkness, we're not just mapping space, we're rewriting the story of our cosmic home. There's a patch of sky about the size of 20 full moons that doesn't just feel cold, it shouldn't exist. Nestled in the cosmic microwave background, the afterglow of the Big Bang, this enigmatic region is colder than the surrounding universe by a hair's breadth. But that tiny difference has astronomers rethinking the very fabric of reality. Dubbed the CMB Cold Spot, it's like a cosmic bruise, a blemish on the infant universe that defies explanation. The numbers don't add up. Based on our understanding of the Big Bang's aftermath, temperature fluctuations this extreme should occur once in every 10,000 universes. Yet here we are, staring right at it. So what could leave such a mark? One theory points to a supervoid, an incomprehensibly vast, empty region of space where galaxies are eerily sparse. If light traverses this cosmic desert, it loses energy fighting against the expansion of the universe, cooling as it stretches into longer, redder wavelengths. But there's a problem. The largest known supervoids can't account for the cold spot's chill. It's like blaming a puddle for a flood. The scale just doesn't match. That's where things get wild. Some physicists suggest this anomaly might be evidence of something far more mind-bending, a collision with another universe. In the chaotic moments after the Big Bang, our universe might have bumped into a neighboring bubble of space-time, leaving behind a gravitational imprint, a cosmic dent. If true, the cold spot isn't just a curiosity, it's a fingerprint from a reality beyond our own, a crack in the door to the multiverse. Yet skeptics aren't ready to rewrite cosmology just yet. Could it be an artifact of how we're interpreting the data? The CMB is a faint whisper after all, and teasing signal from noise is like listening for a single voice in a stadium. Others propose more exotic explanations, like a defect in the early universe's structure, a cosmic knot left over from its fiery birth. What makes the cold spot so thrilling isn't just the mystery, it's the stakes. If it's a supervoid, it challenges our understanding of cosmic structure. If it's a multiverse collision, it reshapes reality as we know it. And if it's neither, well, that might be the most exciting outcome of all, because sometimes the universe's greatest gift isn't an answer. It's a question that forces us to think bigger. And right now, the cold spot is asking the biggest one of all. What else are we missing? There's a phenomenon so subtle, most people have never noticed it, yet once you've seen it, you'll never forget it. Just after sunset or before dawn, when the sky is caught between darkness and light, a faint, ghostly pyramid appears on the horizon. This is the Zodiacal Light, a shimmering veil of cosmic dust illuminated by the sun, stretching upward along the ecliptic like a pathway to the stars. For centuries, it's been mistaken for twilight's last glow or even the first hint of dawn. But this isn't just atmospheric trickery, it's a window into the hidden machinery of our solar system. What makes this glow so mysterious? It all comes down to the dust itself, billions upon billions of tiny particles, some no larger than grains of sand, drifting between the planets. Conventional wisdom pinned their origin on comets and asteroids, the solar system's eternal litterbugs. As these objects collide and crumble, they leave behind trails of debris that slowly spiral inward, creating a vast, diffuse cloud. But here's the twist. Recent research suggests Jupiter might be the unseen architect of this cosmic haze. The gas giant's immense gravity acts like a cosmic shepherd, nudging dust particles from the outer solar system into the inner realms where they catch the sunlight just right. Yet the puzzle doesn't end there. Some scientists argue Mars could be playing a role too. Dust storms on the red planet blast fine particles high into its thin atmosphere, where solar radiation pressure might propel them into interplanetary space. Others point to strange, short-lived bursts of dust production, events we've yet to witness directly, that could be replenishing the zodiacal cloud faster than expected. What's fascinating is how this ethereal glow connects us to the solar system's turbulent past. Every speck of that dust carries a story. The violent collisions of asteroids, the silent disintegration of comets, even the restless winds of distant worlds. By studying the zodiacal light, we're not just observing dust, we're piecing together a cosmic chronicle of destruction and renewal, written in particles too small to see with the naked eye. So the next time you find yourself under a twilight sky, look closely. That faint glow isn't just a trick of the light. It's a whisper from the depths of space, a reminder that even the emptiest corners of our solar system are alive with motion, history, and mystery. And who knows, the answers we're searching for might be hiding in plain sight, dancing in the sunbeams of dawn. Think about the last time you misplaced your keys. Frustrating, right? Now imagine losing half the ordinary matter in the entire universe. That's exactly what happened to astronomers for decades. You'd think something as fundamental as atoms, the building blocks of stars, planets, and even us, would be easy to track down. But here's the cosmic plot twist. About 50% of all baryonic matter, the stuff that makes up everything we can see and touch, seemed to vanish without a trace. For years, this missing matter was one of astronomy's biggest embarrassments. We could account for every proton and neutron in galaxies, stars, and planets, but when scientists tallied it all up, the math fell shockingly short. Where did it go? The answer lies in the universe's hidden architecture, a vast, invisible web of gas filaments stretching between galaxies like cosmic spider silk. These strands, part of the so-called cosmic web, are so diffuse they're practically transparent to our telescopes, but they're not empty. Packed with million-degree gas, they contain enough material to solve the mystery, if only we could see it. The breakthrough came when astronomers switched their gaze to X-rays and ultraviolet light. Ordinary telescopes see the universe in visible light, but hot gas doesn't glow like stars. It radiates in higher energy wavelengths. By tuning into these frequencies, researchers finally spotted the faint glow of the missing baryons, woven into the cosmic web like threads in a tapestry. The gas is so thin, a cubic meter of it might hold just a single atom, yet spread across billions of light years. It adds up to half the universe's ordinary matter. What's wild is how this discovery reshapes our cosmic perspective. The galaxies we admire through telescopes, they're just the glittering nodes where these filaments intersect. The real bulk of matter exists in the spaces between, a ghostly framework holding the universe together. And here's the kicker, we've only mapped a fraction of it. Every new observation peels back another layer, revealing how much we've overlooked in the voids we once assumed were empty. This isn't just about solving a scientific puzzle. It's a humbling reminder that the universe loves to hide its secrets in plain sight. The next time you look up at the night sky, remember, what we see is just the tip of the cosmic iceberg. The rest is out there, woven into the darkness, waiting for us to piece together the full story. Picture a galaxy like our Milky Way spiraling peacefully through the cosmos, its stars tracing graceful orbits like dancers in a cosmic ballet. Now imagine the chaos of a head-on collision, a smaller galaxy plunging straight through the heart of ours, scattering stars like shards of glass. This isn't science fiction, it happened, and the evidence is written in the stars themselves, a celestial crime scene we've only just begun to decode. Meet the Gaia sausage, a whimsical name for one of astronomy's most groundbreaking discoveries. When scientists analyzed data from the Gaia Space Telescope, they noticed something bizarre, a population of stars moving in radical, perpendicular orbits, cutting across the Milky Way's disk like a knife through butter. These weren't just random outliers, they were the remnants of a dwarf galaxy that slammed into ours 8 to 10 billion years ago, a cosmic meal our galaxy is still digesting. The violence of that collision was unimaginable. The smaller galaxy, roughly a quarter the Milky Way's mass, didn't just merge gently, it was torn apart, its stars flung into wild, elongated orbits that still bear the scars of that ancient encounter. Computer simulations show the impact would have sent shockwaves through our galaxy, warping its shape and triggering bursts of star formation. It's like finding fossilized footprints in mud, except these footprints are stars, and the mud is the fabric of space itself. What's even more astonishing is how this discovery rewrites our galactic history. We used to think the Milky Way grew quietly, accumulating gas and stars over eons. Now we know it's a cannibal, growing by devouring smaller neighbors. The Gaia sausage isn't just a relic, it's proof that galaxies evolve through violence, their stories written in the trajectories of orphaned stars. But here's the twist, this might not have been the only merger. Hidden in the Gaia data are other stellar oddity, groups of stars with strange chemical compositions or peculiar orbits. Could these be the ghosts of other galactic victims, swallowed whole and forgotten? Some researchers suspect the Milky Way's halo, the sparse outer shell of stars surrounding our galaxy, is a graveyard of such encounters, each one a chapter in our galaxy's turbulent autobiography. The Gaia sausage does more than fill in the past, it hints at the future. Our galaxy is on a collision course with Andromeda, a titanic merger that will reshape both galaxies in a few billion years. By studying these ancient scars, we're glimpsing the fate awaiting our own cosmic neighborhood. It's a humbling thought. The stars above us aren't just points of light. They're witnesses to a history of chaos, survival, and rebirth, a story we're only now learning to read. There's a number at the heart of modern cosmology, one that should be straightforward, but instead has scientists locked in a quiet, escalating debate. It's called the Hubble constant, and it measures how fast the universe is expanding. The problem, depending on how you calculate it, you get two different answers, 67 or 73 kilometers per second per megaparsec. That might sound like a tiny discrepancy, but in the world of astrophysics, it's a glaring red flag. This is the Hubble tension, and it's not just a quirk of data. It could be the universe whispering that we've missed something fundamental about its very fabric. The first method for measuring the Hubble constant relies on the cosmic microwave background, the faint afterglow of the Big Bang. By studying its subtle fluctuations with telescopes like Planck, scientists can extrapolate the universe's expansion rate over billions of years. This approach gives us the lower number, 67, but there's another way, using pulsating stars called Cepheids and cataclysmic supernova as cosmic mile markers. These local measurements, anchored in relatively nearby space, consistently point to 73. The gap between these values isn't shrinking with better data. If anything, it's growing more stubborn. So what's really going on? One possibility is that dark energy, the mysterious force accelerating the universe's expansion, isn't constant after all. Maybe it's evolving, growing stronger or weaker over time in ways we haven't accounted for. Alternatively, there could be unseen particles, like a new type of neutrino, subtly altering the cosmos's expansion history. Some theorists even speculate about cracks in Einstein's theory of relativity, suggesting gravity might behave differently on cosmic scales than we've assumed. But here's what makes this tension so thrilling. It's not just about fixing a calculation. If the discrepancy is real, it means our standard model of cosmology, the foundation of everything we know about the universe, is incomplete. Imagine building a house only to discover the blueprint was missing a page. That's where cosmology stands today. The Hubble tension isn't an inconvenience, it's an invitation to dig deeper, to question assumptions we've held for decades. Every new observation adds another piece to the puzzle. Next-generation telescopes, like the Vera Rubin Observatory and the Nancy Grace Roman Space Telescope, promise sharper measurements that could finally tip the scales toward one explanation or another. Until then, the Hubble tension remains a tantalizing reminder that the universe still holds cards close to its chest, and when those cards are finally revealed, they might just rewrite the story of everything. The Moon today is a quiet, airless world, its surface frozen in time, its core long since stilled. But hidden in its ancient rocks lies a startling secret. Our lunar companion once pulsed with a magnetic field as powerful as Earth's. This discovery sent shockwaves through planetary science. How could a body so small, with a core just a fraction of Earth's size, generate such a robust magnetic shield? The answer might rewrite everything we thought we knew about the Moon's fiery youth. Magnetic fields are born from churning molten metal deep inside a planet, a process called a dynamo. Earth's dynamo hums steadily thanks to its massive, swirling core, but the Moon, Its core is too small to sustain that kind of activity for long, unless something extraordinary jump-started it. One compelling theory points to cosmic violence. Imagine colossal asteroids, some the size of small planets, slamming into the moon in its early days. These impacts wouldn't just scar the surface, they could have sent seismic waves rippling through the interior, stirring the core like a spoon in a cup of coffee. For a brief, turbulent window, the moon's heart may have roared to life, its molten iron spinning fast enough to generate a magnetic field strong enough to shield its surface. The proof is etched in lunar rocks brought back by Apollo astronauts. When these samples cooled billions of years ago, their iron-rich minerals aligned with the moon's magnetic field, freezing its strength and direction in time like a cosmic snapshot. Analyzing them reveals a magnetic intensity that rivals Earth, something impossible under today's placid conditions. But here's the twist: the field didn't last. Within a billion years, it faded, leaving the moon exposed to the solar wind's relentless barrage. What's fascinating isn't just the moon's fleeting magnetism, it's what this tells us about planetary evolution. If impacts truly powered this dynamo, it means the early solar system was even more chaotic than we imagined, with collisions not just shaping surfaces but altering worlds from the inside out. Other moons and asteroids might have experienced similar temporary awakenings, their cores briefly stirred by celestial hammer blows, yet mysteries linger. Some lunar rocks show magnetic signatures that don't neatly fit the impact theory. Could there have been another mechanism, like tidal forces from a much closer, younger Earth stretching and heating the moon's interior? Or perhaps the moon's core once held lightweight elements that boosted its conductivity, letting it sustain a dynamo longer than physics predicts. Every new lunar sample adds another piece to the puzzle, hinting at a moon that wasn't just a passive bystander in Earth's shadow, but a dynamic world with its own fiery history. The moon's magnetic past is more than a scientific curiosity. It's a reminder that even the quietest places in our cosmic neighborhood were once alive with change. And as we prepare to return to its surface with future missions, who knows what other secrets those gray, dusty rocks still hold? The moon's story isn't over. We've only just begun to read its first chapter. On the morning of June 30th, 1908, the sky above Siberia erupted in a cataclysm unlike anything witnessed before. Eyewitnesses described a fireball brighter than the sun streaking across the heavens, followed by a shockwave so powerful it knocked people off their feet hundreds of miles away. When scientists finally reached the remote Tunguska region years later, they found 800 square miles of forest flattened like matchsticks, trees fanned outward in a radial pattern, their trunks stripped bare as if a giant hand had pressed them into the earth. But the strangest part: no crater, no fragments of rock or metal, just an eerie, untouched epicenter where the trees still stood, scorched and lifeless. This was the Tunguska Event, one of the most violent cosmic mysteries in recorded history. The energy released was estimated at 10 to 15 megatons, 1,000 times more powerful than the Hiroshima bomb. Yet without a smoking gun, theories swirled. The leading explanation points to a stony asteroid or icy comet fragment, roughly 60 meters wide, that vaporized 5 to 10 kilometers above the surface. The heat of atmospheric entry would have superheated the object's interior, causing it to explode mid-air in what's called an airburst. The result: all the destructive force of an impact without the crater. Think of it like a cosmic grenade detonating in the sky, its shockwave doing the damage instead of a direct hit. But Tunguska isn't just a historical curiosity, it's a warning. In 2013, a much smaller meteor, just 20 meters across, exploded over Chelyabinsk, Russia, with the energy of 30 Hiroshima bombs. The blast shattered windows, injured over 1,000 people, and served as a wake-up call. Earth isn't a passive bystander in an orderly solar system. It's moving through a cosmic shooting gallery. Statistically, Tunguska-scale events occur every few hundred years, while smaller airbursts like Chelyabinsk might happen every few decades. The next one could unfold over a densely populated city, with consequences far more devastating than flattened trees. What makes Tunguska so haunting is how little we still understand. Could it have been a fragment of comet Incair which passes close to Earth's orbit, or perhaps a chunk of an extinct comet, its ice is long gone, leaving behind a fragile rubble pile primed to disintegrate? Some even speculate about more exotic possibilities, a microscopic black hole or a chunk of antimatter, though these lack credible evidence. The truth is, without physical remnants, we're left reconstructing the event from second-hand clues, like detectives solving a crime without a body. Yet this cosmic whodunit has reshaped our approach to planetary defense. Today, telescopes scan the skies for near-Earth objects, cataloging potential threats. Missions like NASA's DART experiment test whether we could deflect an incoming asteroid. Tunguska taught us that the universe doesn't give warnings, it simply acts. And as we peer deeper into space, we're realizing just how many unseen hazards might be lurking in the dark, waiting for their moment to streak across the sky and rewrite history in an instant. The question isn't if another Tunguska will happen, it's when, and whether we'll be ready. For years, Mars has been the quiet neighbor of the solar system, cold, dusty, and seemingly lifeless. But in 2013, NASA's Curiosity rover sent back data that sent shockwaves through the scientific community. Brief, unpredictable spikes of methane in the Martian atmosphere. On Earth, methane is more than just a gas, it's a calling card. Over 90% of it comes from living organisms, from the bacteria in our guts to the vast herds of grazing animals. The rest is produced by geological processes like volcanic activity or chemical reactions in rocks. But Mars, it's a world without cows, without swamps, without active volcanoes, at least as far as we know. So where is this methane coming from? The mystery deepens when you look at how these methane spikes behave. Unlike Earth, where methane lingers in the atmosphere for years, on Mars it vanishes within months, broken down by sunlight and chemical reactions. That means whatever's producing it isn't just a one-time event, it's an ongoing process, releasing bursts of gas that appear and disappear like whispers in the wind. Some scientists point to the planet's subsurface as the culprit. Hidden beneath Mars' rusty surface, pockets of water or minerals could be reacting in ways we don't fully understand, producing methane as a byproduct. Others propose an even more tantalizing possibility: microbial life. If tiny organisms are eking out an existence deep underground, shielded from the harsh radiation, they might be exhaling methane just like their earthly cousins. But there's a twist. Not every scientist is convinced the methane is native to Mars at all. Some argue it could hitchhike its way to the red planet aboard meteorites. When these space rocks slam into the surface, the intense heat and pressure could release trapped methane, creating temporary spikes that Curiosity happens to catch. It's a compelling theory, except for one problem. The amounts detected are higher than what most meteorites should carry. So the puzzle remains: is this gas a geological fluke, a cosmic contaminant, or something far more extraordinary? That's where Perseverance comes in. Since landing in 2021, NASA's latest rover has been scouring Jezero crater, a site once flooded with water, searching for clues. Unlike Curiosity, which could only sniff methane in the air, Perseverance carries instruments designed to analyze samples with unprecedented precision. If it finds organic molecules alongside the methane, the case for biology grows stronger. But if the gas appears without those telltale signs, geology might take the lead. What makes this detective story so thrilling isn't just the potential for life, it's the way Mars keeps defying expectations. Every time we think we've figured it out, the planet throws us another curveball. Whether the methane is coming from ancient microbes, hidden chemical reactions, or even falling space rocks, one thing's clear: Mars isn't as dead as it seems. And with every whiff of this enigmatic gas, we're one step closer to uncovering the truth. Venus was always the planet we wrote off, a toxic, scorching wasteland where nothing could possibly survive. Then in 2020, astronomers dropped a bombshell. They detected phosphine gas swirling in its upper clouds. On Earth, phosphine is a chemical red flag. It's produced either in labs or by microbes thriving in oxygen-free environments like swamps and animal guts. Finding it on Venus was like spotting a campfire in a volcano. It shouldn't be there. The discovery sent shockwaves through the scientific community. Could this be our first whiff of alien life, floating 50 kilometers above a world where surface temperatures melt lead? The initial excitement was met with fierce skepticism. Venus's atmosphere is a nightmare: sulfuric acid rain, crushing pressures, and temperatures hot enough to fry electronics. Yet the team behind the discovery pointed to Venus's cloud decks, where conditions are bizarrely Earth-like. At that altitude, temperatures hover around 30 degrees Celsius, with pressures similar to sea level on Earth. It's the one place where extremophiles, microbes hardened by nature's cruelest experiments, might cling to existence. Some scientists even modeled airborne life cycles, suggesting microbes could ride droplets of sulfuric acid, metabolizing and reproducing in this alien aerial ocean. But here's where the mystery deepens. Follow-up studies couldn't confirm the phosphine signal, sparking a tug of war over data interpretation. Was it a calibration error, a misread spectral line, or something more tantalizing, a gas that comes and goes, hinting at sporadic biological activity? The debate isn't just about chemistry. It's about redefining what habitable means. We've long focused on Mars and icy moons, but Venus forces us to ask, could life adapt to a world where the very air is corrosive? Critics argue there must be an abiotic explanation, perhaps volcanic eruptions or exotic chemistry we don't yet understand. Venus does have active volcanoes, and its atmosphere is a cauldron of reactions that defy earthly logic. Yet no known geological process explains phosphine's abundance without invoking biology. That's what makes this puzzle so electrifying. Even if the phosphine turns out to be a false alarm, it's reshaped how we hunt for life. Maybe we've been looking for Earth 2.0 when we should have been searching for life 2.0, organisms that laugh in the face of our textbook definitions. Upcoming missions like NASA Da Vinci and ESA Envision aim to settle the debate by probing Venus's atmosphere with precision. Imagine if they find more than just gas, if they catch a whiff of something unmistakably alive. It would rewrite the story of life in the cosmos, proving it can thrive in the unlikeliest corners. For now, Venus keeps its secrets wrapped in clouds of acid and intrigue. But one thing's certain: the universe just got a lot weirder and a lot more interesting. Saturn's North Pole hides one of the solar system's most mesmerizing puzzles, a swirling, six-sided storm so precise, it looks like it was etched by some celestial architect. Stretching 20,000 miles across, wide enough to fit two Earths side by side, this colossal hexagon has churned in Saturn's atmosphere for at least 4 decades, possibly much longer. Unlike the tempests we know on Earth, which rage chaotically before dissipating, this geometric marvel is unnervingly stable. its razor-sharp edges holding their shape like a cosmic snowflake suspended in time. So how does a planet, a sphere of churning gases, produce something so angular? The answer might lie in the quirks of fluid dynamics. In labs, scientists have recreated rough approximations of the hexagon by spinning liquids at different speeds, mimicking Saturn's layered atmosphere. When a fluid rotates rapidly, turbulence can organize into geometric patterns, with hexagons emerging under specific conditions. But here's the catch: no lab experiment has perfectly replicated the sheer scale, precision, or longevity of Saturn's version. The planet's hexagon isn't just a fleeting alignment, it's a permanent fixture, a structure so persistent it defies the chaotic nature of gas giants. What makes this storm even stranger is its depth. While the hexagon's outline is visible in the upper atmosphere, observations suggest it might plunge hundreds of miles downward, a towering vortex rooted deep in Saturn's interior. Some researchers speculate that the planet's rapid rotation, a day on Saturn lasts just 10.5 hours, combined with its lack of solid surface, creates a unique environment where such a structure can thrive. Others wonder if there's a hidden interaction between Saturn's winds and its powerful magnetic field, a dance of forces we don't yet understand. Then there's the question of why 6 sides. Nature tends to favor symmetry, but hexagons are rare in planetary weather. On Earth, we see them in honeycombs and basalt columns, where efficiency dictates the shape. But on Saturn, the hexagon might be a mathematical accident, a standing wave pattern generated by competing wind currents, like ripples from multiple stones thrown into a pond. Yet even this explanation feels incomplete. Why doesn't Jupiter, another fast-spinning gas giant, have a similar feature? Why does Saturn's hexagon remain so isolated, anchored solely to its north pole? Perhaps the most haunting possibility is that we're witnessing something entirely new, a phenomenon that challenges our understanding of fluid behavior at planetary scales. The hexagon isn't just a curiosity. It's a laboratory for physics we can't easily replicate, a natural experiment playing out in a distant sky. Every time we point our telescopes at it, we're reminded how much we still have to learn about the forces shaping our solar system. For now, Saturn's hexagon keeps its secrets, spinning silently above a world of liquid metallic hydrogen and diamond rain. It's a reminder that even in the vastness of space, nature has a flair for the unexpected, crafting perfect geometry where we least expect it, and leaving us to wonder what other marvels might be hiding in plain sight. Deep in the cosmos, where telescopes usually find nothing but blackness, something impossible is happening. Gamma rays are pouring out of seemingly empty space. These aren't just any photons, they're the universe's most energetic light, packing 1 trillion times the punch of visible radiation. The Fermi Gamma Ray Space Telescope has been mapping these ghostly signals for over a decade, and what it's found defies explanation. Vast regions of the sky, devoid of stars or galaxies, are glowing with gamma rays nobody can account for. It's like walking into a pitch-black room and feeling the heat of an invisible flame. Theories abound, but none fit perfectly. One tantalizing possibility involves dark matter, the universe's most elusive substance. If dark matter particles collide and annihilate, they could produce gamma rays as a byproduct. Imagine 2 shadows crashing together and sparking a burst of light. The empty sky's gamma rays might be the first tangible trace of this invisible cosmic scaffold, a fingerprint left behind by the universe's missing mass. Yet skeptics point out that the signal isn't quite what dark matter models predict. The distribution is patchy, uneven, more like a scattered whisper than a clear voice. Then there's the chance we're seeing light from galaxies too faint or distant to spot. The universe is littered with dwarf galaxies, some so dim they blend into the background. Others might be shrouded in dust, their visible light swallowed before it reaches us, while their gamma rays punch through. But even this explanation falls short. Stack up every known galaxy, add every possible hidden one, and you still don't account for the sheer volume of gamma rays Fermi detects, the wildest idea. That we're glimpsing an entirely new astrophysical phenomenon, perhaps collapsing cosmic strings, hypothetical defects in space-time, are releasing energy as they snap. Or maybe supermassive black holes in the early universe left behind gamma-ray echoes, like thunder rolling long after the lightning's gone. Some theorists even speculate about primordial black holes evaporating in bursts of radiation, their death throes visible across billions of years. What makes these empty sky gamma rays so electrifying isn't just the mystery, it's what they represent. Every unexplained photon is a challenge to our understanding of the cosmos, a reminder that the universe is richer and stranger than our theories dare to suggest. As Fermi keeps scanning the skies, who knows what other secrets might emerge from the darkness? For now, these phantom rays remain one of astronomy's most tantalizing riddles, a cosmic game of hide and seek where the stakes couldn't be higher. Crack this code and we might just unlock the universe's darkest secrets. There's a strange axis running through the universe, one so unsettling, scientists named it the axis of evil. This isn't some cosmic supervillain's lair, but a baffling alignment in the oldest light we can see, the cosmic microwave background. This afterglow of the Big Bang should be a random, isotropic sea of temperature fluctuations, tiny wrinkles in space-time that tell the story of the universe's fiery birth. But when researchers mapped these variations, they noticed something that defies logic. The fluctuations aren't entirely random. Instead, they eerily align with the plane of our solar system, as if the universe somehow knows which way Earth is tilted. This discovery sent shockwaves through cosmology. In a universe that's supposed to be uniform and isotropic, meaning it looks the same in all directions, such an alignment is like finding all the cracks in a shattered windshield, mysteriously pointing in the same direction. The odds of this happening by chance are astronomically low, somewhere around 1 in 10,000. So is it a fluke, a glitch in our measurements, or something far more profound? Skeptics argue it could be contamination from our own galaxy. Dust in the Milky Way or subtle biases in telescope calibration might imprint false patterns on the data. But even after accounting for these factors, the signal persists. Others wonder if it's a quirk of how we're interpreting the observations. The cosmic microwave background is incredibly faint, and teasing real signals from noise is like listening for a whisper in a hurricane. Yet the more data we collect from Planck, WMAP, and other missions, the more stubborn this alignment becomes. Then there's the radical possibility that the axis of evil is a relic from before the Big Bang. Some theories suggest our universe might have been shaped by events in a prior cosmic cycle, leaving behind faint imprints like scars. If true, this alignment could be a window into a reality we've never seen, a shadow of physics operating on scales we can't yet comprehend. Imagine finding a fingerprint on a window, only to realize it was pressed there by a hand from another dimension. What makes this mystery so gripping isn't just the anomaly itself, it's what it represents. If the universe isn't as uniform as we thought, it challenges the very foundation of modern cosmology. The standard model, built on the principle of isotropy, might need a radical rewrite. Or perhaps, like Copernicus realizing Earth wasn't the center of the solar system, we're being forced to confront another cosmic demotion. Maybe we're not just insignificant in space, we're seeing hints that the universe itself has a preferred direction, a hidden structure we've only just begun to glimpse. For now, the axis of evil remains one of cosmology's great unsolved puzzles. It's a reminder that even our most profound theories are works in progress, subject to revision with every new discovery. And as we peer deeper into the cosmic microwave background, we might just find that the universe's first light still has secrets to reveal, secrets that could reshape everything we think we know. Imagine a particle that doesn't behave like a particle at all, something that slips between the cracks of physics as we know it, defying the tidy categories of the standard model. This is the bizarre realm of unparticles, a theoretical concept so strange it sounds like science fiction. The idea emerged when physicists noticed certain particle interactions producing energy signatures that didn't match any known rules. Instead of discrete, quantized behavior, these anomalies hinted at something fluid, almost fractal, like a substance that doesn't act like matter or energy as we understand them, but something in between. The term unparticle was coined to describe this enigma. Unlike electrons or quarks, which have well-defined masses and properties, unparticles seem to exist in a sort of quantum fog, scaling in ways that don't fit traditional particle physics. Picture trying to measure a cloud. It has substance but no sharp edges or fixed form. Unparticles might explain some of the universe's biggest mysteries, like why gravity is so weak compared to other forces. If gravity's influence is leaking into an unseen dimension mediated by unparticles, it could finally bridge the gap between quantum mechanics and Einstein's relativity. But the implications go even deeper. Dark matter, the invisible glue holding galaxies together, has eluded detection for decades. What if it's not made of particles at all, but unparticles, entities that don't interact with light or ordinary matter in any way we've thought to look? This would mean our entire search strategy, from underground detectors to colliders, might be chasing shadows. Unparticles could be right in front of us, invisible because they operate outside the rules we've written. Of course, skepticism is healthy. Unparticle theory is still speculative, with no direct experimental proof. Critics argue these anomalies could stem from mundane sources, instrument errors, overlooked background noise, or even incomplete models of known particles. Yet the possibility remains tantalizing. If unparticles are real, they'd represent a seismic shift in physics, forcing us to tear up textbooks and rethink reality's foundations. What's thrilling isn't just the science, it's the audacity of the question itself. We're so accustomed to particles behaving predictably that the idea of something breaking those rules feels revolutionary. Unparticles challenge us to imagine a universe far stranger than we've dared to dream, where the fabric of reality might be woven with threads we're only beginning to glimpse. And if history's taught us anything, it's that the universe loves to surprise us just when we think we've got it figured out. It throws us a curveball from the frontiers of the unknown. At the very edge of our solar system, where the sun's influence wanes and the true interstellar void begins, something strange stands guard, a mysterious boundary so potent it bends the rules of cosmic physics. When NASA Voyager probes, humanity's farthest-flung emissaries, crossed this invisible line, their instruments lit up with an unexpected surge of cosmic radiation. This wasn't just a gradual fade into deep space. It was as if the probes had slammed into an unseen wall, a celestial checkpoint marking the end of the sun's domain. Scientists call it the heliopause, but its behavior is anything but ordinary. For decades, we imagined the boundary between our solar system and the galaxy beyond as a gentle transition, like a river merging with the ocean. Instead, Voyager revealed a turbulent no-man's land where the sun's magnetic field collides head-on with interstellar winds, creating a chaotic buffer zone. Imagine two weather fronts crashing solar particles, charged with the sun's energy, pile up against the incoming gusts of galactic material, forming a shimmering barrier of supercharged particles. But here's the twist. The intensity of cosmic rays here defies prediction. At the heliopause, radiation levels spike dramatically, as if some unseen force is amplifying the chaos. Some theorists suggest this could be the work of the local interstellar cloud, a vast region of slightly denser gas and dust our solar system is currently drifting through. Like a ship cutting through fog, the sun's heliosphere, the protective bubble of its magnetic influence, might be compressing this interstellar material, creating a shock wave that energizes incoming particles. Others propose a more exotic explanation: magnetic reconnection, a process where the sun's field lines snap and realign, unleashing bursts of energy that supercharge the barrier. But the most tantalizing possibility, that the galactic barrier isn't just a physical phenomenon, it's a cosmic shield. Earth's atmosphere protects us from solar radiation, but the heliopause might serve a similar function on a grander scale, filtering out the deadliest galactic cosmic rays before they reach the inner solar system. Without it, the radiation environment closer to the sun could be far harsher, potentially shaping the conditions for life in ways we're only beginning to understand. Yet mysteries remain. Why does the barrier's strength fluctuate? Could there be similar structures around other stars, or is ours unique? As Voyager continues its lonely journey into the abyss, each byte of data it sends back peels another layer off this cosmic onion. The galactic barrier isn't just a boundary, it's a living laboratory, a place where the laws of physics play out in ways we never anticipated. And as we stand on the threshold of interstellar space, one thing becomes clear: the universe doesn't just end where we expect it to. It keeps surprising us right up to the edge. What if everything around us, the stars, the oceans, even the thoughts in your mind, weren't real, not in the way we think at least? This is the heart of the simulation hypothesis, a theory that suggests our universe might be nothing more than an elaborate digital construct, an advanced civilization's version of a video game. At first glance, it sounds like something ripped from science fiction, but some of the brightest minds in physics and philosophy take it seriously. The idea isn't just wild speculation, it's rooted in the very quirks of reality that science struggles to explain. Take quantum mechanics, for example. At the subatomic level, particles behave in ways that defy common sense. They can exist in multiple states at once until observed, as if the universe is rendering details only when we look, like a video game optimizing processing power by loading graphics only when a player turns their head. Then there's the unsettling precision of the universe's mathematical structure. The laws of physics follow equations so elegant, so finely tuned, it's as if they were coded by a programmer. Even the speed of light acts like a cosmic frame rate, a maximum processing limit nothing can exceed. But who would build such a simulation? One chilling answer comes from philosopher Nick Bostrom's trilemma. If any civilization could reach technological maturity without destroying itself, and if it had the desire to simulate conscious beings, the odds suggest we're far more likely to be one of countless simulations than the original, base reality. Think about it. If advanced civilizations run even a handful of ancestor simulations, the simulated minds would vastly outnumber the real ones. Statistically, you're probably not at the top of that pyramid. Yet the hypothesis isn't without its critics. Some argue it's unfalsifiable, a fun thought experiment with no way to test its validity. Others point out that even if our reality is simulated, it changes nothing about how we experience life. Pain still feels like pain, love like love, but the most intriguing counter comes from physics itself. If the universe is a simulation, where's the evidence of computational limits? Glitches in the matrix. So far, reality runs flawlessly, without the crashes or artifacts you'd expect from even the most advanced software. What makes this idea so captivating isn't just the question of whether we're living in a simulation, it's what the debate reveals about our place in the cosmos. The simulation hypothesis forces us to confront the nature of consciousness, the limits of science, and the possibility that reality might be far stranger than we've dared to imagine. Whether it's true or not, one thing's certain: the universe has a way of keeping us guessing, leaving us to wonder if we're the players or the played. From the inexplicable flicker of Tabby's star to the cosmic whispers of the Wow signal, the universe has never been shy about keeping us guessing. These 25 mysteries aren't just unsolved puzzles, they're invitations to rethink everything we thought we knew. Take dark matter. It's everywhere, shaping galaxies like invisible hands, yet we still can't say what it actually is. Or consider Saturn's hexagon, a storm so geometrically perfect it feels like nature showing off. Every time we think we've cracked the code, the cosmos throws another curveball, proving reality is stranger than even our wildest theories. What's exhilarating isn't just the mysteries themselves, it's how they redefine the scientific process. The pioneer Anomaly taught us that even a tiny discrepancy can upend decades of assumptions, while the Hubble Tension now threatens to rewrite cosmology itself. These aren't dead ends, they're doorways. When Venus's Phosphine hinted at life, it forced us to expand our definition of habitable to include acid clouds and crushing pressures. When Oumuamua zipped through our solar system, it reminded us that interstellar visitors might be weirder than we ever imagined. Science doesn't progress by clinging to comfort zones. It thrives on anomalies that refuse to fit the mold. But here's the real magic. You don't need a telescope to join the adventure. Every time you look up at the night sky, you're part of this grand detective story. Maybe you'll spot a meteor streaking overhead, a fleeting visitor from the asteroid belt, or perhaps you'll marvel at the Milky Way, knowing its spiral arms hide black holes, rogue planets, and maybe, just maybe, signals we haven't learned to decipher yet. The universe isn't just for astronomers, it's for anyone willing to wonder, to question, to stay delightfully unsettled by the unknown. So what's next? Maybe we'll finally detect gravitational waves from the Big Bang, or catch a radio transmission that shatters our solitude. Maybe the James Webb Telescope will reveal atmospheres on distant worlds with chemistry that screams life. Or perhaps the next great mystery hasn't even crossed our radar yet. One thing's certain: the cosmos will keep surprising us, not just with answers, but with questions we haven't even thought to ask. The greatest story ever told isn't locked in the past, it's unfolding above us right now, written in starlight and static, waiting for curious minds to tune in. The universe isn't a puzzle to solve, it's a conversation that never ends, and you've got a front row seat.